In this video, we're going to talk about Triton, Neptune's largest moon, and the only big moon in the solar system that moves in a retrograde orbit. That means that it moves in the orbit opposite of the planet's spin. So if Neptune spins like any other planet in the solar system, which he is, Triton moves in the opposite direction. Now, Triton most likely haven't formed around Neptune. It most likely formed in the Kuiper belt, where Pluto and a bunch of other dwarf planets are technically there. Now, Triton is an interesting body on its own, not only because of its retrograde orbit, but also because of other interesting features on its surface. So in this video, we're going to talk about some of those features of Triton and talk a bit about the origin that we think, based on the evidence that we have, that from where it came from and basically what happened and how it was captured by Neptune a long time ago. Now, let's start this video with the fact that Triton is the biggest moon of the about 17 or so moons of the planet Neptune. Now, Neptune is a very big ice giant planet. However, most of its moons are very small. Most of them are comparable to asteroids or some kind of comets. However, very few of them, if ever, are round, and Triton is the biggest moon around Neptune. Now, Triton overall is made of a combination of methane, ice, other ices in many ways, water in it. Its composition is very similar to the dwarf planet Pluto. Now, Pluto has 5 moons around it, which we're not going to talk about it now. However, considering the chemical signature is basically identical, that means that Triton and Pluto and other dwarf planets came from the same area, which is the Kuiper belt. Now, the Kuiper belt is a vast area of comets and icy bodies like Pluto and such. So, if Triton came from there, that means we definitely can tell that it used to be a dwarf planet with a partner around it. Now, how capture works, it's pretty simple. When a body goes closer to another body, if that body is slow enough by speed, then the bigger body can capture it gravitationally and make it to go around in orbit. Now, when Triton first was born, it was born most likely with a companion around it. So it was a binary dwarf planet system, or a binary system if you will. However, most likely Triton was moving at a slower rate than its companion, which means that as soon as those two bodies came near Neptune, the faster moving one was ejected from the system, and the slower moving one, which is Triton in this case, came closer to Neptune, and Neptune captured it gravitationally and make it go into an orbit around it. However, for some reason, instead of going in the same direction as the planet spins, Triton gone on the opposite direction. Most likely because it was captured and not born with the planet. However, that process of retrograde orbit makes that this is a fight that Triton cannot win, because Neptune is much bigger, much more massive, has more gravity. All in all, is just much bigger body, which means that Triton eventually is going to turn itself into shreds, into pieces, because it's gravitationally going to lose the battle at the end of the day. However, Triton has features that are much more interesting right now. First of all, it has a very thin atmosphere, like extremely thin. However, it's still there and still allow for some wind to blow and to create something we basically call black chimneys. And those basically just geysers that go from under the surface up in the air and then goes like this. Now, this moon was captured basically in pictures by the Voyager spacecraft a long time ago, in the 1980s and 1990s. It's I should say in the 1980s, at the end of 1982 with the Voyager 2 mission, and 1979 with the Voyager 1 mission. However, they were able to deduce that the moon is, first of all, still active. His surface is pretty young, pretty featureless in terms of There is no craters, which means that some process is working to replenish the surface and make it smoother. However, there are fissures, there are canyons, there are features that shows that there is a battle going on between Neptune and Triton itself. I'm going to talk a little bit now and show you, but I'm going to tell you a little bit other dry data before we're going to start showing some pictures. Now, Triton is less than 3,000 kilometers wide, which is it's the 7th largest moon in the solar system. However, it is most likely mostly composed from about 45% water ice by mass, between 30 to 45%. And overall, it has many interesting ideas, but we're going to talk about them I'm going to show you a little bit about them. Now, this picture specifically shows some of its side, as you can see, this area in here. It looks pretty featureless because something is replenishing the surface. Now, of course, as you can see, Neptune goes this direction, while Triton goes into the other direction. And even though the orbit of Triton is opposite in direction and tilted 23 degrees compared to typical moon's orbit, in the plane of Neptune's equation, this is where usually the moons will be moving around, but Triton is different because it's not just going in the opposite direction, it's also going in a different angle than the planet itself, which is something unique specifically to this moon, which is interesting. Now, if you can see even here, this is the Kuiper belt, which is where Triton most likely came from, and here you can see the four gaseous giants, and this is where the asteroid belt is. And in between you can see some bodies here and there. So this is a nice little map to kind of show the scale of the Kuiper belt. As far as we know, it could be even larger. Now, this is masses of all the Neptunian moons. As you can see, Triton is the most massive and the biggest, but all the other moons are tiny, tiny pebbles compared to Triton itself. Now, you can see right about, you can see that this is size comparison, of course. This is Triton, this is our moon, and this is the Earth itself. As you can see, the Earth is the biggest, of course, and Triton is slightly smaller than our moon by scale, but just in a size comparison, this was basically most likely by the Voyager 2 spacecraft, shows the moon, part of it, from the backside as Voyager 2 was going away from it. This is some of the features, clouds, because it has a very thin atmosphere, you can still see some clouds there. So this is an interesting thing. And there are, of course, older terrains. There are a bunch of different terrains on its surface. It's a very interesting features it has on it. This is an interpretive map that shows the areas on Triton itself from something older to something maybe newer and anything else. Now, as you can see, there are volcanic province, there is volcanic activity, there is some other activities going on the surface, and as you can see, the surface is pretty smooth, it doesn't have too many craters on it, if any. Now, this is another area, and here you can actually see the dark streaks, the chimneys, that you talked about, which is basically releasing nitrogen to the atmosphere. This is nitrogen geysers that are erupting from under the surface, which is a very interesting thing nonetheless. And here you can see two large cryolava lakes. Cryolava lakes means there are some cold lakes, not lava, but water that came to the surface and freeze over. In a way, you can see the impressions of those lakes, if you will, here and right about here. This is another picture of those. You can see there are black chimneys, there are cracks, if you will, on the surface where most likely water or other chemicals came through. Here you can see those. This is terrain view from 130,000 kilometers by the Voyager 2, which cross-cutting Europa like double ridges. Europa is the moon of Jupiter, which we're going to talk about later, but those lines are the same as the moon Europa, which means you basically get that most likely under the surface there could be a water ocean, a salty one in that. Again, you can see cryovolcanic weld plain, which is But you can see barely any craters, just one about here. So relatively recent activity, which is very interesting. Here you can even see basically how it works. Charged particles from Neptune, from the solar radiation, go into his ionosphere, which is intense, while its atmosphere is pretty thin. And what drives those plumes? Most likely, water under the surface, which goes up through fissures in the ice shell, which is the crust of Triton itself. From there you can even get those plumes, as you can see right about here. So if you think about it, those plumes are going from down the surface. And here you can see Neptune on top and Triton in the bottom, 3 days after flyby of Voyager 2. Here is Triton itself, and this is Neptune, so the size is huge between them. Here you can even see some maps, color maps that have been made using the Voyager 2 data, and Voyager 1. The same about here. It just shows something. Now it came back. Now, of course, Triton itself, as you could see, could harbor an ocean of liquid water. Why? Because once, a long time ago in its orbit, it most likely wasn't circular like today. It was elliptical. Because when Neptune captured it, most likely it was started as a very elliptical orbit. But then, over time, it circularized enough so it became very circular orbit. But the energy from that time it was very eccentric still created what we call tidal heating. The same thing that happens with Jupiter and its moons. Tidal heating means that when the body moves closer to the more massive body, it's stretched, and when it goes back, it relaxes, and it goes like this every time through the orbit. Now what that creates is heat. That heat will melt the ice in the interior of the moon and could create a salty water ocean, or at least a water ocean. We don't know if it's salty or not, but it most likely is. We just can't be too sure. Now what that creates is basically the fact that this water is going to be under the ice sheet, under the mantle, under the crust of Triton, and over time, through cracks in that ice, water can go out in steam, or in this case, because there is also nitrogen in the ice and methane and other ices, if you will, they melt, and eventually you can get something like those black plumes, which basically releases nitrogen, water vapor, and a few other stuff out to the surface. Now, the thing is, the heat goes by the ionosphere, which is very active, as you could see from the pictures, because of the charged particles that go from Neptune's atmosphere or Neptune's magnetosphere and the solar radiation. It combines together to create a very active ionosphere. An ionosphere, it can generate some heat to keep that thin atmosphere still alive, which also allows basically those plumes to keep going. But again, it's mainly because Triton has able to keep a lot of heat through his eccentric orbit that it was when it first was captured by Triton by Neptune a long time ago. So when he was captured by Neptune, he was in eccentric orbit, and it was tidal heating, flexing and relaxing through its orbit, and that created a lot of heat. That heat is still there, despite now being in a circular orbit. So, plus the fact that it's in the retrograde orbit also helps to conserve some of that heat, most likely because it's a fight between two very big bodies. So gravitational heat can create a lot of energy, and as you know, water is a very good conductant of, well, a lot of processes. Water can even heat themselves to a degree through some biochemical processes that we still not fully understand. Now, beyond the fact that Triton is the only big moon of Neptune, other than that, it's, well, most likely, if the ocean that he has under the surface, it might harbor life, but we don't know. But it's still the only large moon in the solar system that goes in the opposite direction. This is what makes him truly unique compared to the other moons in our solar system. And the fact that he has geologic activity and cryovolcanism in some way, so it's a very interesting body. And one more kind of a note, Neptune, like the other moons, has rings around it, but Triton doesn't do anything to help those rings keep there. But again, the fact that this moon was also tilted compared to the orbit plane of other moons or other bodies in that system also makes it quite unique in many ways. So this was really the Triton with explanation about it. Hope you enjoyed the video, and I will see you in the next video. Goodbye.